Hi, everyone. Thanks for being here. My name is James Saryawini. I'm a software development engineer at AWS, and I work on various Python tooling, AWS CLI, Boto 3, Boto Core, a couple of other tools. And today I'm going to be talking about next-level testing. And it's next-level testing revisited. So the motivation behind this talk was that a lot of the code bases I work on have unit tests, they have integration tests, a pretty decent test suite. And I was always curious if there were additional types of tests that I could be writing that would help find bugs that I wasn't aware of, help prevent regressions, and just in general make the software that I maintain easier and make that a little bit, give us more confidence in the changes we're making, that we're not breaking anything. And so I started looking at different types of tests, property tests, fuzzing tests, that kind of thing, and was able to give an initial talk about this earlier in the year. And since then, I've been trying out a couple more ideas, and I wanted to share them with you today, hopefully get some interest in them. And there's two main things that I want to talk about today. Property-based testing and fuzz testing. I think these ones, there's some really interesting stuff here, and I want to give you some examples of some of the projects I work on and how I've used these tests. So a lot of stuff to cover, and I know we started a little bit late, so I just want to jump right in here. The first one I want to talk about is property-based testing. So quick show of hands, who has either used hypothesis or has heard of property-based testing? Okay, about a quarter of the room. So we'll do a quick motivating example here. We'll move pretty quickly through this. So let's say that I have a function here, or some tests for a function. And in these tests, this is more or less the traditional way you would write this. You could clean this up a little bit with something like pytest.mark.parameterize if you wanted. But we started thinking, can we do better? Is there a general property here for this absolute value function? And we can think, yeah, so the main property is that whatever it returns is a non-negative number, so it has to be greater than or equal to 0. And what we can start with is just generating a bunch of random numbers and seeing how everything works, making sure that we get a value greater than 0, so you don't care about the specific result, just some property of it. And in essence, that's really what property-based testing is all about. You write assertions about properties of your function, you generate a bunch of random data, and then you make sure that that property holds. And tools like hypothesis have some interesting things above what we just saw in our code sample there. Particularly, one of the nice things that it has is the ability to minimize an example. So if it finds some input data that violates some property, we'll try to shrink that test case to as small an example as possible so that you have a very succinct test case. And the other nice thing about hypothesis is that it has a lot of powerful test data generation. So in our example previously, we just need integers, but this is a really powerful system to combine a lot of advanced input test data. You can create arbitrarily nested JSON data, a lot of cool stuff. And we can use hypothesis to change our previous example from that for loop that we had where we're picking random numbers to this. So essentially all you do is you just import from hypothesis, and you decorate your test function with this given, tell it what type of test data you need, and then given will do the looping for you, and it'll call your test function, I think, 1,000 times by default. And it will pass in whatever random value you needed it to generate. In this case, x will be an integer, and then you make whatever assertions you want. So this is the essence of property-based testing. And if this is a new concept to you and you want to learn a little bit more, I'll have a link at the end about a talk I gave previously that goes into more detail about this type of property-based testing and a few worked examples. One of the things that's really interesting to me is state-based testing using hypothesis. So the idea here is that instead of the test we've been looking at so far where it generates one test data point and you have to make an assertion purely based on that data point, instead what if it was a sequence of actions? So instead of just X, it said do one, or do A, do B, and then do C. And that's what state-based testing is all about. So it has the same benefits when you use hypothesis, that if it does find a failure, it will try to shrink that example or the sequence down to some minimal example. And in their documentation, I believe they use data structures as a motivating example. So I think with a balanced tree, if you add and delete various values to the tree, you can always assert that it should be balanced. So what I wanted to do was give you an example of how I've used this and where I found it really helpful. And I'm going to talk about the issue of doing deployments. So one of the projects I started about, I think early last year is this thing called Chalice. It's a serverless framework for writing, or it's a Python framework for writing serverless applications. If you haven't checked it out, you should. It's pretty cool. But we're not going to look too much about the details on that. I just wanted to show a specific aspect, which is how you would test deployments. So on the left-hand side, we have some decorator-based API that's saying that we want to create some Lambda functions. And if we run our deploy command, so imagine there's, say, a Chalice deploy command line thing or something that actually creates these resources. On the right-hand side, you can imagine we're actually creating AWS Lambda functions in AWS. And if you're not familiar with AWS Lambda, it's just a way to, you give it code and it has a Python runtime, it will import your code and run it for you. And it's really, really nice service, but we're not going to look at the specifics of Lambda. For the purposes here, just imagine for each thing that we're decorating, we need to deploy some resource. So we can substitute S3 bucket or a DynamoDB table, something like that. But what we can think of is, okay, at this time here, right, time T1, we're going to create some functions. And then let's say we now want to create a new function. So we update our code. We say, here's some new function that we want to create called hello PyGotham. And we run deploy, and that should create a new resource over in AWS. And now at time T2, we record that fact. And now let's say we want to do a deletion. So say we don't like this particular function and we want to delete it. So we remove it from our code base, we run deploy, and what should happen is the resources should be gone. And we now have the time T3, we're deleting these functions. So this is similar. This is what state-based testing is about. It's a sequence of operations that you want to, whatever your system is to actually execute. And at each step, you can check invariants or certain properties about whatever you've done so far. So in deployments, in the case of deployments, there's a couple of things that we can check. If we add something in our code and we do a deploy, we should see a create call similarly with delete. And I want to give you an example of something. Give you an example of a bug it can catch. So here's one. Let's say that I have, this is the current state of the world. I have 3 resources here and the Lambda function on the right-hand side. And so at time T1, we're going to delete a function. So we go ahead and delete it. And then our deploy command, let's say we update our internal state to delete the function, but we forget to actually make the delete API call. So we have this resource that's unreferenced, right? And so let's say at time T2, we say we want to create the function again. So we do the normal thing, we add it to our code, we run our deploy, and in this particular case, if you use create function and the function already exists, you get an error back. Now, once you know this, right, it's pretty easy to fix, but the point here is that it can highlight these types of issues. Like, did you check if you delete a function and then create it with the same name that you don't get an unexpected result? So that's really what state-based testing can help with. And this would be a sample input that it would have you execute. And these are called steps. So now that we've seen an example of what this can do, how do we actually do this in code? Hypothesis helps out a lot. So this is, it has 2 versions of this. There's a rule-based state machine and a generic state machine. I like the generic state machine. It gives you a little bit more control, and I found that helpful for me. But we'll go very quickly through how this works. I'll try to give you some realistic-looking code, but really I just want you to get the gist of how you would do this yourself. So the basic steps here. You just subclass from generic state machine here, and then you implement your init, which initializes whatever state you have. You then have a set of steps that are valid. So in our case, you could say you can add a function or you can delete a function. Those are the valid steps. And then hypothesis will pick a step and ask you to execute it, and then you execute that step, whatever that means for your test. So here's a somewhat simplified version of how this looks like for Chalice, for how we would test this. First, we initialize it, so we have some object that represents our app here. And then we have our 2 actions. So this is, first part is saying, if there's no functions yet, you can't delete any functions. So if there's no functions, the only step you have right now is to add a function. And that's what this is doing. This is using the hypothesis strategies here. So a sample here would say, we're going to give you the method we want you to invoke, say add function, and then some random name. So it's just going to generate a random function name for you. Otherwise, oh, and I should mention that it is just a list of functions. So Lambda functions here is just some Python type. Otherwise, if you can if you have at least one Lambda function, you can then either add a function or delete a function. And here what we're saying is randomly pick one of our functions that we know about and just delete it. And then this syntax here is just saying now you have a choice. So hypothesis will pick one or the other. Okay, so once we've done that, we look at our execute step. So our execute step is pretty straightforward. Again, we're going to be passed the method that we want to execute and then the argument here. So something like add function. And then what we do is we will update our internal state. So in this case, if it's an add function, what we're going to do is instantiate some object. Think of this as like a model or something that represents the Lambda function. And then we add it to our list of Lambda functions. So we're just updating state so far. And then for the delete case, we're past the function that we've been asked to delete, and we just remove it from our list. And so we've updated our internal state, and then we have this last step here, which is the deploy, the mock deploy. So I won't show you this code. It's fairly involved, but at this point you have two options if you're doing this on your own. You can either do a real deploy, so actually deploy your app to whatever it is you're deploying to, if it's AWS or your own servers, do the deploy and then actually query the state to make sure that it meets whatever your properties are. Or you can even just use mock or fake components and verify properties about that. And if any of you were at the previous talk, you are all now experts in that. So it really is up to you, but the nice thing is you can use either of these, like this approach works for either of these cases, whether you're doing an integration test or you want to just use a unit test here. So hopefully this gets you interested in state-based testing. You can use the same framework with hypothesis. It's really helpful, and it gives you, it makes you think about if you do A, B, and C in a specific order, does that meet like what you're expecting? Is it doing anything unexpected? And I found it really helpful for testing deploys. All right, so that was the property-based testing stuff. I want to move over to fuzz testing. Fuzz testing is interesting to me. So it's almost the same idea as property-based testing. So that's you generate random input, right? And then you feed it to whatever the code under test is, and you make sure it doesn't do anything crazy. And in this case, it can be either it only raises a known exception, or it returns a value, and it's a value that you expect. And you can do the same type of property style assertions. So say, if it does give me a return value, then I'm going to assert that it's a list of strings or some other property, right? And the fuzzer that I've used that I really like is AFL. It is coverage guided, so it looks at how far it's able to execute your code, and based on that, it figures out how it should mutate your test data. And it's really fast and really, really easy to integrate with Python projects. And I guess most importantly, it has Python bindings. So if you pip install Python AFL, you'll have this nice fuzzer. You'll have libraries and a few command line utilities you can use. And all you have to do to integrate with this is write a driver script that reads random data from standard in, and then feeds that to whatever code you want to test. So for example, this would be the bare minimum you would need to use for a fuzzer. You just have whatever test function that's going to accept random input, and then you have the AFL integration part, which is just a function that says we're going to loop, we're going to do an infinite loop here, and then we're going to just call main. And in each iteration through main, we're reading from standard in, which is the randomly generated data, and we feed that to our test function. So this is a pretty straightforward process, and again, you can use this for fuzzing, all sorts of things, really. The way you invoke this, there is a PyAFL fuzz command, and you give it where you want it to write results. So it's going to write out a lot of data, and if it finds any crashes, that's where it'll put it. And then you give it this sample input of this input corpus. So ideally, you want it to start from a set of known valid inputs and then start mutating those rather than just starting from some random set of input data. So you show it what valid input looks like. So if you're parsing, or I'm sorry, if you're fuzzing a parser, you might have valid expressions or something so it knows what good ones look like. And then you give it the script that reads from standard in, which is this previous script you looked at. And that's all you need to do, and it'll start running, and you can let it run for quite a while. And it will create a results directory. So in this directory, the part that matters the most is the crashes directory. That's a thing that actually shows you what crashed. So the file names have miscellaneous metadata. You don't really need to worry about them too much. It just says what it had to do to get to this state. But the contents of this file is the input it passed the standard in that crashed your program. And so that's really what you want to be looking at. And I will mention, if this is a little bit new to you, there's a talk linked at the end that has a worked example of some of the cool stuff you can do. It's using AFL fuzz to fuzz a lexer and a parser. But one of the questions that comes up is, can't we just use coverage here? So if you think about it, if I have 100% line coverage and 100% branch coverage, do I really need a fuzzer? I mean, isn't that all we really need? So I wanted to illustrate that with a crazy example, but something that shows something that's really easy to miss with just branch and line coverage. So let's say that I have this code here, and I write a few tests for it, right? So the first test is I pass true, false, false. So what this is doing, it's going to hit that first case that says A is true. So we're just going to take 4K, 4K to the first power, which isn't that bad, right? It's just going to allocate a 4K array of zeros, or a list of zeros. And we do the same thing with B. So we say false, true, false. And so now green is lines covered, right? Red is lines missed. So we do that. And so far that looks good. And we do it again in the third case. And now if we look at what we have here, it's interesting because we have 100% line coverage, right? We've hit every line of code, and we have 100% branch coverage. So every if statement has been true and false, right? We've evaluated every single one of those if statements. But there's a really interesting case that we've missed, which is what happens when each branch is taken. So if I pass it true, 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 right now I'm allocating 4K to the third power, which is a really big number. And at 8 bytes an element to store the pointers there, it comes out to 512 gigabytes. So we have a case here where, if it's one value is true, we're allocating a 4K array. If two values are true, we're allocating 128 megabytes. And if three of them are true, you will probably either crash your program or at least slow it down by quite a bit. And so this is the kind of thing that Fuzzer can check. It's not just checking branch coverage, it's also checking the specific trace of execution, the specific edges that are taken for a given invocation. And as it explores these new cases, that's where it starts to mutate the data. So it does more than just branch coverage. Okay. So one of the places I've used this is with this query language, James Path. It's in a couple of tools, AWS CLI, Ansible, a couple of other things. And the way that it works is you give it some sort of string expression, and then you give it the input data, and it will search through the input data. So like A dot B will give you this value here, right? And it has a number of other things as well. You can search into lists, you can do or expressions. There's a lot there. So one of the examples I've used in the past is how we were able to fuzz this for the compilation part. So there's a compiler, right, and it parses into an AST, and so we can get a bunch of data generated by AFL and feed it into there and make sure that we're either parsing things correctly or we're raising the right exceptions, and we're not generating type errors or runtime errors or anything weird like that. But one of the things I started looking at was how do we actually use multiple input values. So in this case, not only do I want to parse or fuzz the expression, but also the sample input data. So what I started experimenting with was trying to think of it as a file format, right? So you give it sample corpus of files, and if we treat the files as the pseudo file format, does that actually work very well? Can we actually start creating a bunch of sample data that AFL Fuzz will magically figure out? So I had this set up here where I just have the expression as the first line, some delimiter, and then expression on the bottom here. Or sorry, the input data as JSON here. And then I created a bunch of those sample inputs. And ideally what AFL Fuzz should figure out is that as it's running it, if it changes anything in the delimiter, right, then it's not going to generate any new coverage, any new traces coverage. So it'll stop mutating that. It'll figure out that we shouldn't touch that. And my script now is not that much more complicated. As you can see, I'm still reading from standard in, but all I'm really doing is partitioning them. So I'm splitting on whatever that delimiter key is, doing some basic sanity checking here. So making sure that there's an expression to parse, and then making sure that the partition is there and didn't get messed with, and that we can load the JSON document. And once we get that far, we can then feed that into our thing that we want to test. So this is the type where one is a string and then one is a parsed JSON value. So you get that working, and you let that run, and how well does that actually work? Well, I took this example, and I annotated it a little bit and added some stats to keep track of what cases we hit. And this is a sample run. I forget how long I let this run. But what was interesting to me is that the bad delimiter part actually we never hit that case. It knew not to touch that as it was doing its initial analysis. And so we got the case that we'd expect. So there's bad JSON when it tries to mutate the JSON document and produces something invalid. There's bad James Path expressions. And then there's also the success case where it mutated everything and it was still able to produce a valid result. So overall, this worked out really well and actually helped find a bug in, I think it's the actual evaluation part where it's searching through the AST. So it was really helpful in finding those types of bugs. Okay, so the main summary here is if you're using fuzzing, you can use it for more than just an arbitrary byte string. If you actually treat it more as a file format and start to get more structured data, it will eventually figure out how it can map those to multiple parameters. All right, so that is property-based testing. We looked at fuzz-based testing. I think we even came in under time with a late start, which is awesome. Here's some links to check out, and there's also a link at the bottom for the previous talk. If this was a little too fast and you want a little bit more background material, that has a lot more worked examples, and definitely check it out. And then you can follow me on Twitter if you want to. I occasionally tweet about some of this testing stuff. And that is it. Thank you, everyone. Oh, awesome. We do have time for questions. What time do we finish? Oh, okay. Yeah, we have time for questions. Everyone has questions. Oh, yeah, sorry.
So there's kind of a big spectrum of testing, right? From like unit tests or integration style tests to like really expensive acceptance testing. It seems to fall more on the expensive acceptance testing side, but I'm interested to hear from you. How many of these kinds of tools do you think you use in practice? Are they once every once in a while?
Yeah, that's actually a really great question. In fact, in cutting, I cut out that part exactly, so I guess I'll spend a quick minute on that. So really, I've prepared an answer. So yeah, I think that unit tests and integration tests are like the main part of the development lifecycle. And what I found is that property-based tests, it's almost a vertical concern. So as you saw in that deployment example, you can use it for integration tests, you can use it for unit tests. The one thing that is always a little weird is that there is an element of randomness to it, right? So you don't really want your CI system to just randomly fail. So the way that I think of this is more of an exploratory type of test that you run, not as part of your core CI system. So and this is just my workflow, but the way that I usually see this is, on the one hand, with the unit tests and the property tests are all part of your CI system. So those are usually the mostly deterministic. I mean, there is still an element of randomness with the hypothesis testing. But the fuzz and another one we had to cut for time, the long-term testing, those are more of like the exploratory tests that don't get run that frequently, or at least get run either nightly or as you're working on that particular feature, you kick that off through still Jenkins, whatever your CI system is. But those feed back into unit tests. So usually every error, every crash I found from a fuzz test can be translated into a deterministic unit test. And even with hypothesis, you don't have to use unit tests directly. There is a way to call out specific examples if you do find something that violates the hypothesis that you want to run every time. Yes?
We found with hypothesis that we had different profiles. So when everybody's running the unit test, they run it with a smaller number of examples.
Yep.
When the developers who are working on this particular feature run it, they run
Yep.
it with a lot more examples.
Yep. And so just to elaborate on that, there's an option where you can have settings for hypothesis, and we have something similar as well. So when you're doing development, you can have it run with fairly quick settings to do a quick sanity check. And then say when you're running on Travis, we bump up the number of iterations and we have it do a lot more exhaustive things. So you want an example of that? The link there has an example of how that's used in one of the projects I work on that has a sample Travis .yaml if you want to see how to do that. Cool. Any more questions? Yeah, I'll put the slides online. I don't know if there's a conference place they're putting the slides. If not, I'll upload them and tweet out a link. All right. Thanks, everyone.